Alright, let's go. Number 11, Kepler 186f, the first Earth-sized planet in the habitable zone. On April 17, 2014, astronomer Elisa Quintana stood before the world and announced a discovery that quietly reshaped our understanding of where life might exist. The Kepler Space Telescope had identified a planet 582 light-years away in the constellation Cygnus, almost exactly Earth's size, orbiting within the habitable zone of its star. This planet, Kepler 186f, marked the first time humanity confirmed that Earth-sized worlds can exist in regions where liquid water could potentially flow. What makes Kepler 186f especially unsettling is how sharply it challenges long-held assumptions about habitability. The planet orbits an M-type red dwarf star and receives only about 32% of the stellar energy Earth gets from the Sun. By traditional models, it should be a frozen wasteland, locked in a permanent ice age harsher than anything found on our planet, sitting near the outer edge of its star's habitable zone where scientists once expected nothing but ice and permafrost. But here, our understanding breaks down. Kepler 186f's true nature depends on a single factor we cannot measure from such distance: its atmosphere. With sufficient greenhouse gases, perhaps only a few times Earth's carbon dioxide levels, this seemingly frozen world could sustain liquid water oceans beneath a dim red sky. The discovery revealed something profound: red dwarf stars, which make up nearly 70% of the stars in our galaxy, can host Earth-sized planets in their habitable zones. If even a small fraction retain warm atmospheres, the number of potentially habitable worlds is not in the millions, it is in the billions. Number 10, GJ667cc, the super-Earth beneath three suns. On November 21, 2011, astronomer Guillaume Anglade-Escute announced a discovery that sounded more like science fiction than astronomy. Just 24 light-years away in the constellation Scorpius, a planet roughly 4.5 times the mass of Earth was found orbiting within the habitable zone of a red dwarf star. But this star was not alone. It was part of a triple star system, meaning that from the surface of GJ667cc, the sky could be illuminated by three suns. What makes this world truly unsettling is not the alien view overhead, but the conditions on its surface. The planet orbits its host star every 28 days at a distance much closer than Mercury orbits the Sun, a configuration that almost certainly results in tidal locking. One hemisphere would face permanent daylight, while the other would remain in eternal darkness, a contrast that should create temperatures too extreme for life. Yet GJ667cc receives nearly 90% of the energy Earth gets from the Sun, mostly in infrared light. If the planet possesses a thick atmosphere, heat could be redistributed across its surface, creating a narrow but stable habitable region along the terminator, the boundary between day and night. Unlike Earth's shifting seasons and chaotic climate cycles, this twilight zone could remain unchanged for billions of years. Life evolving there would know a stability our planet has never experienced. Number 9, Kepler 62f, the atmospheric paradox planet. On April 18, 2013, NASA announced the discovery of a 5-planet system located about 1,200 light-years away in the constellation Lyra, the outermost world. Kepler 62f immediately stood out for the wrong reasons. Orbiting at the cold edge of its star's habitable zone, the planet receives only about 41% of the stellar energy Earth gets from the Sun. Early estimates suggested it was larger than Earth and destined to be a frozen, lifeless iceball drifting through space. Every conventional climate model predicted permanent global glaciation, and for a time, scientists largely moved on. But in 2016, atmospheric research led by astronomer Aomawa Shields revealed a different possibility. Her team's model showed that if Kepler 62f possesses carbon dioxide levels just 3 to 5 times higher than Earth's, combined with even modest amounts of methane, the planet could sustain liquid water year-round. The greenhouse effect alone could transform a frozen wasteland into a temperate ocean world. This realization carried an unsettling implication: habitability is not defined by distance from a star alone, but by atmospheric composition, a factor we cannot directly measure for most exoplanets. Worlds we once dismissed as too cold and beyond hope may actually be warm, stable environments where life quietly thrives. Kepler 62f suggests that the true habitable zone of the galaxy is far larger than we ever imagined. Number 8, TOI 700d, the nearby discovery with a hidden atmosphere. On January 6, 2020, during the 235th meeting of the American Astronomical Society, astronomer Emily Gilbert announced a discovery that brought potentially habitable worlds closer to home. NASA's TESS mission, designed to survey the nearest and brightest stars, had detected an Earth-sized planet just 101 light-years away, orbiting within the habitable zone of a quiet red dwarf star. This planet, TOI 700d, measures about 1 times Earth's radius, receives roughly 86% of the stellar energy Earth gets from the Sun, and completes an orbit every 37 days. What made TOI 700d especially compelling came 3 years later. In January 2023, the James Webb Space Telescope turned its instruments toward this nearby world and detected possible signs of an atmosphere. The data were preliminary, But the implications were immediate. Climate models suggest two starkly different versions of TOI 700d. In one, the planet is a global ocean world, wrapped in thick clouds with no exposed land. In the other, it is a colder desert planet, with water trapped in vast polar ice caps and liquid existing only near the boundary between light and darkness. In both cases, tidal locking creates a permanent dayside with remarkably stable conditions. Unlike Earth's shifting seasons and climate swings, TOI 700d's environment could remain unchanged for billions of years. Earth's habitability is fragile and temporary, this world's may be constant. Number 7, Kepler 22b, the first confirmed habitable zone planet around a Sun-like star on December 5, 2011, NASA announced a discovery many scientists had expected would take decades to achieve. The Kepler Space Telescope had confirmed a planet orbiting within the habitable zone of a G-type star, the same class as our Sun, located about 620 light-years away in the constellation Cygnus. Kepler 22b completes an orbit every 290 days and receives roughly 25% more stellar energy than Earth, placing it comfortably within the range where liquid water could exist. Its host star burns at nearly the same temperature as the Sun, making this system, at first glance, feel reassuringly familiar, but certainty ends there. Kepler 22b is about 2.4 times Earth's radius, placing it in a poorly understood category between rocky super-Earths and gaseous mini-Neptunes. Its mass remains unknown, and without mass, scientists cannot determine its density or composition. More than a decade after its discovery, we still do not know whether Kepler 22b is a rocky world with deep oceans, a global water planet with no land at all, or a small gas world wrapped in an uninhabitable atmosphere. What makes this unsettling is not what Kepler 22b might be, but that it was the first of its kind. We proved Earth-sized or Earth-like orbits exist around Sun-like stars, yet the true nature of the first one we found remains hidden, reminding us how limited our view of distant worlds still is. Number 6, LHS 1140b, the super-Earth that just revealed its atmosphere in April 2024. Astronomer Charles Cadieux and his team announced findings that reshaped how scientists think about planets around red dwarf stars. Using observations from the James Webb Space Telescope, they detected possible signs of a nitrogen-rich atmosphere surrounding LHS 1140b, a super-Earth located just 49 light-years away. This was not simply another atmospheric hint. It was evidence that a rocky planet in the habitable zone of a red dwarf might retain a long-lasting, protective envelope of gas. LHS 1140b is massive by Earth standards, with about 1.7 times Earth's radius and nearly 6 times its mass, creating surface gravity roughly 30% stronger than what we experience. Moving across its surface would feel heavier, more demanding. But that same gravity could be its greatest advantage. Earth is slowly losing its atmosphere to space as solar wind strips lighter elements away over time. LHS 1140b's stronger gravity could hold onto its atmosphere far longer, preserving stable conditions for billions of additional years. Its host star is also unusually calm for a red dwarf, producing far fewer destructive flares. Combined with a stellar lifespan measured in trillions of years, this world may offer life an opportunity Earth never had: extreme longevity. While our planet's habitability has an expiration date, LHS 1140b could remain stable long after Earth becomes uninhabitable. Number 5, Kepler 452b, Earth's older cousin with extra time. On July 23, 2015, NASA held a press conference that quickly captured global attention. Astronomers announced the discovery of a planet many headlines called Earth 2.0, located about 1,400 light-years away in the constellation Cygnus. Kepler 452b orbits a G2-type star, the exact same spectral class as our Sun. The star's temperature is nearly identical, and the planet completes an orbit every 385 days, strikingly close to Earth's 365-day year. Kepler 452b sits at almost the same orbital distance we do, receiving only about 10% more stellar energy than Earth. On paper, it appears familiar, but the most unsettling detail is not its similarity, it is its age. Kepler 452's host star is roughly 6 billion years old, making it about 1.5 billion years older than the Sun. If life emerged on Kepler 452b following a timeline similar to Earth's, it had an additional 1.5 billion years to evolve. When life there may have reached our current level of development, Earth was still dominated by barren rock. Long before complex multicellular life appeared, human civilization has transformed the planet in just 10,000 years. Now extend that timeline by a billion years. Kepler 452b is not Earth's twin. It may be a glimpse of what Earth could become given more time than we will ever have. Number 4. Proxima Centauri b, the closest potentially habitable world. On August 24, 2016, astronomer Guillaume Anglade-Escud announced a discovery that transformed interstellar travel from distant speculation into a real engineering problem. Proxima Centauri, the star closest to our solar system at just 4.24 light-years away, was confirmed to host a rocky planet within its habitable zone. Proxima Centauri b is close enough that a spacecraft traveling at a fraction of the speed of light could reach it within a human lifetime. This world is not a distant dream, it is, in theory, reachable. But proximity reveals a darker reality. Proxima Centauri is an M-type red dwarf, one of the most violent classes of stars capable of sustaining fusion. It unleashes powerful stellar flares that bombard the planet with extreme levels of X-ray and ultraviolet radiation. Proxima Centauri b orbits extremely close to its star, completing a full year in just 11 days, and is almost certainly tidally locked, with one side facing permanent daylight and the other eternal night. Conventional models suggest its atmosphere should have been stripped away long ago, yet some scientists propose a radical alternative. The same radiation that seems hostile could drive chemical reactions impossible on Earth, providing energy for unfamiliar pathways to life. Between constant day and night lies a narrow terminator zone where temperatures may remain stable. Life evolving there would adapt to conditions Earth has never experienced. Number 3, TRAPPIST-1e, the Goldilocks planet in a 7-world system. On February 22, 2017, astronomers announced a discovery unlike anything seen before, about 40 light-years away in the constellation Aquarius. An ultra-cool red dwarf star known as TRAPPIST-1 was found to host 7 Earth-sized planets, all orbiting closer to their star than Mercury orbits the Sun. Among them, TRAPPIST-1e stood out. It sits squarely in the system's habitable zone, receiving about 66% of the stellar energy Earth gets from the Sun, placing it in the ideal range for liquid water. In size and composition, TRAPPIST-1e is the most Earth-like exoplanet ever discovered, with a density suggesting a rocky world rather than a gas-dominated one. But what makes this system truly unsettling is its age. TRAPPIST-1 is approximately 7.6 billion years old, giving any potential life on its planets more than 3 billion additional years to evolve compared to Earth. The planets are locked in near-perfect orbital resonance, their gravitational interactions maintaining remarkable stability over billions of years. From the surface of TRAPPIST-1e, neighboring planets would appear enormous in the sky, passing regularly across the dim red face of the star. If life arose there, it did not just have favorable conditions. It had time, far more time than Earth ever will. Number 2, K2-18b, the Hycean world with a possible biosignature. On September 11, 2023, astronomers announced a finding that sent a quiet shock through the scientific community. Using the James Webb Space Telescope, researchers analyzed the atmosphere of K2-18b, a planet located 124 light-years away, and detected a molecular signal consistent with dimethyl sulfide. On Earth, this molecule is produced exclusively by biological activity, primarily by microscopic marine organisms. No known geological process is able to generate it in significant quantities. What makes this discovery unsettling is that K2-18b should not be habitable by traditional standards. The planet is about 2.6 times Earth's radius and more than 8 times its mass, placing it in the category of many Neptunes, worlds long considered hostile to life. But K2-18b defies easy classification. Earlier observations revealed water vapor, methane, and carbon dioxide in its atmosphere, suggesting a new type of planet known as a Hycean world. With a hydrogen-rich atmosphere above a global ocean, conditions there would be extreme. With immense pressure and an ocean hundreds of kilometers deep beneath a thick, reddish sky, the dimethyl sulfide signal remains debated, and follow-up observations are underway. But if confirmed, it would mean we have not just found a planet better for life than Earth. We may have found a planet where life already exists, thriving in conditions nothing like our own. Number 1, LHS-475b, the quiet Earth-sized world with an uncertain future. In August 2023, astronomers using the James Webb Space Telescope confirmed the existence of an Earth-sized planet orbiting a red dwarf star just 41 light-years away. The planet, LHS-475b, is nearly identical to Earth in size and completes an orbit every 2 days, placing it extremely close to its host star. At first glance, this proximity suggests a hostile environment, yet what makes LHS-475b remarkable is not what we know, but what we do not. Early observations failed to detect a thick atmosphere, but they did not rule one out. The planet could possess a thin, tightly bound envelope that remains invisible to current instruments. Its host star is unusually calm for a red dwarf, producing fewer violent flares than expected. If LHS-475b retains even a modest atmosphere, stable conditions could persist on its surface or along its terminator region. This world represents a growing realization in astronomy. Some of the most important habitable planets may not announce themselves clearly, they may exist quietly, just beyond our ability to confirm, waiting for time and better tools to reveal what they truly are. If you want to see more videos like this, click the video on screen now and make sure to subscribe.